Hi everyone, I'm recording this on Thanksgiving Monday. I hope you had a wonderful Thanksgiving with your family. Today's lesson is about similar triangles. So, similar triangles are ones which always have the same angles. So in the two triangles that I have here, I have the larger triangle, ABC, and the smaller triangle, DEF. And you can see, if I look at these two angles, and these two angles, and these two angles, they're all the same, and that's what I've summarized here in this table. So angle A is the same as angle D, so angle A equals angle D. Angle B equals angle E, and angle C equals angle F. So that's what it means for two triangles to be similar. They have to have the same angles. There's one other thing that the triangles have to have, and that is they have to have a proportionality or scale factor between their sides. So again, based on this picture, you can see that this side, the vertical side, if you will, AB, has to be the same proportion to side length DE as this side, BC, is to EF. And that's basically what's happening here. This proportion, AB divided by DE, has to be equal to BC divided by EF. And we just call that the scale factor. We call that the scale factor. And usually what we do when we set this up is we try and put whichever side is larger, in this case AB is the larger side, obviously, it's the bigger triangle. So we put the larger one in the numerator and the smaller one in the denominator. That way we get our scale factor should be greater than 1. Okay, so we can say that that's how much larger the bigger triangle is than the smaller triangle. There's actually a little bit more to it than that. So for example, if you add up all the side lengths of triangle ABC, you get the perimeter. That's how far around you would go if you walked around the triangle. And at the same time, you could do the same thing and get the perimeter for triangle DEF. So if you then took this perimeter of the large triangle and divided it by the perimeter of the small triangle, you would get, once again, this scale factor, how much larger the big triangle is as compared to the smaller triangle. The area of the triangles, again, follows this scale factor, but it's not just a scale factor, it's actually the scale factor squared. So if you take the area of triangle ABC, just using half base times height, that usual formula that we've used, and then divide it by the area of triangle DEF, you would get the scale factor squared. Okay, we're going to go over a lot more about this in class, doing a lot more problems with this, but I just thought I would mention it now. One of the skills we will have to work with quite a lot is working with proportions, particularly solving them, solving for an unknown that's in a proportion. So one proportion, a simple one that we might need to work with would be, for example, 1 divided by 6 equals x divided by 21. Now in this case, we have fractions, and I know that, like many, you probably don't really like working with fractions. However, in this case, if you remember back to when we worked with fractions the last time, with linear equations, we used a trick that you can use here to good effect, and that is we're going to multiply by the denominator to clear the fraction. So in this case, you see that we have 6 in our denominator on the left side. So that means that we have to multiply by 6 so as to clear it. However, if we multiply by 6 on the left side, we must also multiply by 6 on the right side. And keep in mind that this 6 only multiplies the numerator. Over here and here, it does not multiply the denominator. Okay, so then we have 6 times 1 is 6 divided by 6 equals 6x divided by 21. Now you might look at this and say that it doesn't look like I've really done anything, but keep in mind that 6 divided by 6 is just 1. So at least I've made the left side a lot simpler. Also, I can use the same trick on the right side. I see I have my denominator of 21, so I'm going to multiply this by 21. But then I must also multiply this by 21, so as to keep the balance. So on the left side, 21 times 1 is 21. And on the right side, 6 times 21 is 126. So I have 126x divided by 21. Now you might wonder what that is, but in actuality, this simplifies to 6. Just 6. So now I have, if I bring this up here, 21 equals 6 times x. And now this can be solved pretty easily, although perhaps not exactly. We're going to divide this by 6 on both sides, and finally end up with 21 divided by 6, which actually, if I work it out, is 3.5. Oops, equals x, excuse me, equals x. Okay, so that's going to be our, that will be the value of x that will keep the proportion, that will maintain this proportion that we started with back over here. If I take 3.5 and divide it by 21, I get the same number, the same decimal number, as 1 divided by 6, and you can check that out for yourself. Let's do one more example, and this one will be a little bit more complicated, but the same kind of idea is going to hold. We're going to take 1 divided by 9 and solve that for x plus 10 divided by x plus 5. Okay? Now, some people, when they look at this, they get the sense they're not quite sure what to do here, and they think, oh, I should be able to divide the x's like this. But in actuality, you can't do that, because that kind of breaks the rule in the sense where we have addition. We have addition in the numerator, a variable plus 10, and the same thing, a variable plus 5 in the denominator. And if you were to divide out an x, you would just be left with, well, I guess 10 divided by 5, I suppose, depending on how you did it, which is always 2. And depending on the value of x, there's no reason why, like if I chose x equal, a number like 1, 1 plus 10 divided by 1 plus 5, that's 11 divided by 6, that's not equal to 2. So you can't just divide x. The bottom line is you can't just divide x out of both numerator and denominator like that, because x is a variable. We have to solve for it. If we divide it out, there's nothing to solve for. So we can't do that. So what we need to do instead is we need to go back and do exactly what we were doing before. We're going to multiply this by 9, and thus multiply this by 9. Now this 9 on the right has to multiply everything in the numerator. We have to be a little careful there. On the left side, this is nice and simple. Those 9s divide out, and we're left with just 1, the one that was previously here in the numerator. That's all that's left. The numerator on the other side, if we multiply this 9 in and expand it, we have 9x plus 90 divided by x plus 5. Okay, so things are looking good there, but you might say, well, that looks horrible. And keep in mind that well, you're right, it kind of does, but we're going to do the same thing. We're going to multiply this expression by x plus 5. And we're also going to multiply this by x plus 5. And we do that because it's easy to multiply x plus 5 by 1. That just gives us x plus 5. There's nothing simpler than that. And then on the other side, we again have this division. X plus 5 divides x plus 5 evenly. And all we have left is 9x plus 90. Okay, and from this point we can then solve the way we normally do. We have a linear equation in one variable. So we can subtract x from both sides and subtract 90 from both sides, and we have negative 85 equals 8x, just like that. And then we're going to go up here and solve this. So we have x equals negative 85 divided by 8. Okay, so I don't know exactly what that number is. It's negative 10 and a bit, but I'm just going to leave it as a fraction because that will be fine for now. So I'll bet that when you were looking at this original expression, you wouldn't have thought to choose a value of x that first of all was a fraction. You probably would try a whole number or something, and then also you probably wouldn't try a value of x that was negative like that. That's might be kind of surprising. But keep in mind that if this number is, if the numerator is negative and the denominator is negative, then when we divide them, we get a number which is in fact positive. So it might be surprising, but it does check out, and you can work it out. You can do a verification on the right side, excuse me, if you put in negative 85 over 8 for x here and here, and you work that out, you will find that that is exactly 1 over 9. Okay, so that's it for today. I'll see you in class. Have a great day.